So we're group 14. We made the Boilermaker Commemorative Clock. I'm Alex. This is Curtis, Roy, and Daniel. So a little bit about how our clock works. We can run a little mechanism for you here. So the train, which is powered by a servo motor and the Arduino, will run around and act as the minute hand. And so every minute it will run and stop 366 degrees or a minute further. We have lights on our engineering fountain, which are to act as seconds, and right before the train moves, they'll light up rapidly and intensely so that you can you know when the minute's coming up. Our clock is going to be marketed toward the older generation, so sort of as like a desk toy, something that you could have on your desk while you work. And Curtis is going to talk a little bit about our features.
Yeah, so we call it an unmistakable likeness, and that's because we went ahead and designed our clock with as much nostalgia as possible. As Alex said, we're looking more to market towards the Purdue faithful, whether they be alumni of the school or not. But as you can see, we have the Boilermaker Special, we've got the Purdue P, the engineering fountain, and the bell tower. And so we went through and we modeled them as close to the actual thing as we could. And then as you can see in the finishing with the paint and things like that, we want to make sure that when you see this clock, maybe if you did graduate from Purdue, say 25 years ago, that when you see this clock in your desk, that you're reminded of your days and the memories you had at Purdue, and maybe the enjoyment you've had coming back to the campus to visit.
Now, I'm going to talk to you about what's really unique about our clock. Our clock uses a really unique mechanism called the Ferguson clock mechanism, or it might also be called a lantern pinion mechanism. This concept was originally developed by a astrology professor named James Ferguson in 1760. Our clock has specially designed gears that run the Ferguson mechanism. These gears were designed. These gears were designed to run a 12:1 gear reduction system mechanism. We designed those gears using our knowledge of the mechanical engineering classes that we have taken so far at Purdue. Our clock also uses an Arduino to run the motion of the mechanism. Prior to using the Arduino, we had to learn how to use that. The really unique thing that our clock is all about is that it is not a toy, it is a clock.
And now with this clock, you're able to have a sense of nostalgia, right, about your past or your present here at Purdue. So like we were talking about earlier, these special features allow you to just remember your good days at Purdue. It allows you to then display it, to honor your university and to take pride in where you came from. And also the unique gears that we have on here, the unique gear mechanism, kind of allows the user to enjoy watching the clock run. It allows the user to have some visual stimulus there, enjoying watching this unique mechanism run, because it's not an ordinary clock mechanism like Roy was talking about. It's the Ferguson mechanism, which isn't used in many clocks. And so it's a special, different kind of mechanism that we use that's very enjoyable to watch run. Along with that, you can then put this either in your dorm room, in your home, or on your office to just display your pride in Purdue and to honor your university that you came from. We'd like to say also a special thank you to Professor Romani, Senthil, and Dev. They gave us a lot of help throughout this process and gave us a lot of direction, both through the building process and in the design phase. We'd also like to thank all of you guys for showing up and just supporting each group's hard work and all the work that we've put into these projects. We wanted to open it up to questions now, if any of you have questions for us.
So it doesn't work right now. One of the main problems that we had was to get a motor that would fit inside of our clock and also be able to have enough torque to move our mechanism. And most of the motors that they make are for like small like airplanes or toys like that. So they have a high RPM but not enough torque. So I think something if we could do differently would be to maybe go and try and find something with higher torque.
So I'm trying to understand, is it the train that goes around as the,
Yeah, so the train will go around once a minute. It's going to be stationary right up until the minute is up.
okay.
So just a part of the design that's unique is the fact that it's all coaxial. And so we've got the DC motor in the back that rotates on the first set of pinions. And for every 60 rotations, that then turns into one rotation of the next pinion. So it basically transfers from the seconds and minutes into the hour hand on the front, which is this green on the EC. So the fact that it's all coaxial is why we were kind of reduced to using the one motor, which we couldn't get enough torque out of. But then once every minute, there's a second motor in the back, like Ro was talking about, triggered by the Arduino, that then sends the train around as your actual minute hand.
So the train does a full lap.
It does a full lap and then ends a minute further, so 366 degrees further than it originally was.
It takes about 5 seconds for that train to do its full rotation, and then after the train's done the full rotation, it stops at the next minute tick mark and waits there until another minute, and then does another full rotation in about 5 seconds, and it does that each minute.
Now does you say you had a tough time finding a motor with the proper torque for the right size. Does that motor exist?
I think it would exist
Does it
somewhere.
exist
It's
with no sound?
with no sound.
Well, no sound. I mean, I can imagine every minute hearing.
I mean, I don't know. Would have to actually go and purchase it.
Yeah, we tried 4 different motors on this model, and we found one that had enough torque, but it was too large because we designed this for a certain size. So it would be possible to redesign the mechanism for a motor that would run the clock, but our problem was we were already constrained because we designed it for a smaller motor size that we thought would have enough torque, and then ended up not having enough due to the amount of friction that we experienced.
And then the only design adjustment at that point would just be making it wider to give us more
Right.
room in there.
Well, I think it is, what's interesting is, obviously this is it is targeted at Purdue demographic, right? And, I mean, I'm pretty sure you can make the mechanism work somehow or the other, but the key is the mechanical challenges the technical challenges is on one side, but the other is the experience, right? The experience of this. What kind of experience are you designing with this, right? You're trying to use this as a linkage between the individual, right, an alum, and their experiences of years past, right, and keep it relevant to the context of where you are today. That's the essential bridge, right? If that's the goal, then I think the question that Doug had asked was about would the train go around, every minute, which would be absolutely horrific experience to endure it. I would put that away or turn it off if it were really doing that. Maybe every hour, perhaps, right? It would do. So you could actually anticipate it and say, well, let me wait 1 more minute and it's going to go do a round. So something like that is fine. And I think I would probably not clutter it too much with the tower and this and 100 other things. Just let it be clock, right? And just let it be the train. That's fine. It's almost like a bird that comes out and beeps 10 times, 12 times, whatever. It's an analogous idea to that. So that's fine. I think the experience question, I think you're getting there. It is there in terms of the usage of color, usage of the design of the whole mechanism, and it's transparent, which is quite fascinating. And those are the key things, I think, to stay focused on that. It could be a viable thing. It is a kind of a toy.
Yeah.
It's not quite a toy, as you said, but it's kind of a toy. It can be interesting.
Just along those lines, just to keep on building off of that, with your input, obviously, the Purdue aspects of this could be interchanged. If we were to actually, take this to market, this could be expanded to, other Big Ten schools, certainly any other university. And like you said, you can change out the Boilermaker special for, any school's mascot and that kind of thing to gain that experience with whoever the individual might be.
It's the kind of thing that, particularly, it should emphasize the Ferguson mechanism with, fairly narrow of people are gonna understand that, mostly mechanical engineers. You might wanna consider just a mechanical drive on, like an 8-day wind-up instead of electric motor.
Okay.
Ferguson didn't have any electric motors to deal with.
No, I did
I
not.
don't believe
No.
so.
I used the hand crank method, yeah. So.
Well, thank you.
Yeah.
Okay, thank you.